Okay, so we'll discuss capital investment analysis methods. We'll be discussing methods that can be some of the methods that can be used to choose among capital investment projects or to decide whether or not a certain capital investment project should be accepted. And let's just try to go over these practice questions. Some of these questions will just have to be absorb very objective questions. They do not rely. They do not require so much analysis. Okay. Okay. Here, so number one, all of the following are methods that aid management in analyzing the expected results of capital budgeting decisions. Except the answer here is future value cash flow method. We do not have this method in uh, analyzing various capital investment projects. So we have your rate of return method, which you will try to get the rate of return that a particular project can give. Uh, we have your discounted cash flow method, wherein you will have to get the present value or to discount the cash flows that will be provided by the project. This is used in many methods, particularly in your net present value method. A second, discounted cash flow methods for capital budgeting focus on, the answer here is letter D, both A and C. So both inflows and outflows. So basically under the DCF or the discounted cash flow method, the focus would be on cash flows. I think we have discussed or mentioned this in our discussion on the basic capital budgeting process. Next, the capital budgeting method, which calculates the expected monetary gain or loss from a project by discounting all expected future cash inflows and outflows to the present point in time using the required rate of return. This would be your net present value method. This is basically the definition for your net present value method. You get the present value of the inflows, you get the present value of outflows, the net amount would be the net present value of the project. If it has a positive amount, then that would mean that the project is an acceptable project. If the present value of cash inflows is greater than the present value of cash outflows, then that would result in a positive NPV. NPV or net present value. Number four, which capital budgeting techniques measure all expected future inflows and outflows as if they occurred at a single point in time. So again, this is another description of your uh, net present value. Okay, but this will not just be your net present value. Your answer here would be letter D, both A and B, because in the internal rate of return, you would also uh, assume that the you're trying to look for in the internal rate of return, you're looking for the rate of return that would make the present value of the outflows equal to the present value of the outflows. So both the net present value and the internal rate of return makes an assumption that the cash inflows and outflows occur at at a single point in time, which is time zero here at the start of the investment project. Number five, the capital budgeting method that calculates the discount rate at which the present value of expected cash inflows from a project equals the present value of expected cash outflow is this is basically the definition for your internal rate of return. So the answer here would be letter D. Next, an important advantage of the net present value method of capital budgeting over the internal rate of return So you'll notice in the handout, uh, many questions would involve a comparison of the various investment analysis methods. Okay, so this question is an example of uh, a question asking you to compare, uh, in this case, the net present value and the internal rate of return. So, again, an important advantage of the net present value method of capital budgeting over the internal rate of return method is letter B, the net present values of individual projects can be added to determine the effects of accepting a combination of projects. Letter A is definitely wrong. The net present value is uh, expressed in terms of monetary amount. Uh, okay, so the answer here would be letter B. Number seven, the method that measures the time it will take to recoup or recover in the form of future cash inflows the total dollars invested in the project is called your payback method. So basically, your payback method is expressed in terms of time, in terms of years. How many years will it take you to recover your investment? How many years will it take for the inflows to equal your investment? Okay, so that is your payback method. So at this point, you're being reintroduced to three methods already: the net present value method, the internal rate of return, and your payback method. There's also a variation of the payback method, your discounted payback method, that instead of using the absolute value of the inflows, you will get the present value of the inflows. And normally, the discounted payback period would be longer than uh, the regular payback period. Because again, you'll be using discounted cash flows under the discounted payback method. Okay, but I don't think there will be a lot of questions involving discounted payback method. The questions here would revolve around the regular payback method. Okay, so in the payback method, you would get the payback period, and it is expressed in terms of time or years. So net present value is expressed in terms of monetary amount. The internal rate of return is expressed in terms of a percentage, and your payback period is expressed in terms of time or years. Number eight, the payback period is best defined as letter A, the time it takes to receive cash flow sufficient to cover your initial investment. Okay. Next, uh, still on payback, the payback method of capital budgeting approach to the investment decision uh, highlights the liquidity of the investment, because the focus here would be on the ability of the project to give you inflows, especially at the early stages of the project. Okay, number 10. A problem associated with the payback method is letter B, it doesn't include cash flows after the payback period. So under the payback method, you will just measure at what period will you be able to fully recover your investment. And if you're choosing between mutually exclusive projects, you might end up rejecting a project that has very uh, significant inflows, a project that can give you significant value through inflows after the payback period. Okay, so normally you will have a low or a short payback period if you have large cash flows early on. Okay, but what if a huge chunk of the cash flows of the project are earned in the later stage or later part of the term of the capital project? Okay, and with that, that's why NPV is generally considered a better method compared to the payback method, because your NPV, your net present value method, considers all the cash flows. Okay, considers all the cash flows throughout the term or the life of the project. Uh, all the other choices are incorrect. There is no assumption that cash flows are reinvested. Letter D is actually another knock on your payback period because it does not use the time value of money concept because again it uses the absolute amount of cash inflows. Number 12, sorry, 11, a major disadvantage of the payback period is that the answer here would be letter D, statements B and C. Okay, again, it ignores the cash flows beyond the payback period and does not directly account for the time value of money. Okay, these two are the uh, significant disadvantages of the payback period. The prominent advantage of using the payback period is simply its simplicity. Uh, the simplicity in determining the payback period. Number 12, calculate the payback period for the following investment. A machine costs 100,000 with installation cost of 115. Cash flows are expected to be 26 per year for the next 7 years. Okay, so again, the goal here is just to determine at what point will you be able to recover your initial investment. Okay, so the first step here would be to get your initial investment. So is your initial investment here 100,000 only, or will it include the installation cost? And the answer is it would include the installation cost. Okay, so your total investment here, which you will try to recover, would be 115,000. So after 1 year, you will have an inflow of 26. So definitely you have not yet recovered your uh, investment. 2 years, that would be 52. So still no. 3 years, that would be 78. Okay, and then after 4 years, it would be uh, 104. So you still have not recovered your uh, total investment. Okay, so after 4 years, you have uh, 104. So at that point, how much have you not recovered? You have not recovered 115 minus 104, you will have 11. So you divide 11 by 26, you would get 42 or 0.42. So that means you would be able to recover the entire 115,000 in 4.42 years. So the answer here is delta. Next, the net initial investment for a piece of construction equipment is 1 million. Annual cash inflows are expected to increase by 200 per year. The equipment has an 8-year useful life. What is the payback period? So, if the net benefit from getting the equipment is an increase in your 200 in your inflows of 200,000 per year. So the focus here would just be on the incremental cash flows. So incremental cash flow as a result of the acquisition of the equipment would be 200 per year. How many years will it take you to recover your 1 million investment? Okay, so if you have 200,000 per year, obviously you'll be able to get back your 1 million after 5 years. So the answer here would be delta. You can just divide 1 million by 200,000 and you would get uh, 5 years. Next, net present value is calculated using, you're asked what rate is used to get the present value of the inflows and outflows. The answer would be the required rate of return. So you use the rate of return required by the company. And normally, what will be used in the problems as the required rate of return would be your hurdle rate or your WACC or your weighted average cost of capital. Okay. So the answer again in number 14 would be Bravo. Um, Next, given the following information, calculate the net present value. Initial outlay is 50,000. Required rate of return is 10. Current prime rate is 12. And cash flows for the next 4 years are 60, 30, 40, and 50. Okay, so basically the initial outlay of 50,000 is already at present value because it is a cash flow at year zero. Okay, and then what you have to do here is to get the present value of the cash flows of 60,000, 30,000, 40,000, and 50,000. But you'll have to do this separately because the discounting period for these cash flows are not the same. The 60,000 will be discounted for 1 year. The 30,000 will be discounted for 2 years. The 40,000 will be discounted for uh, 3 years, and the 50,000 would be discounted for 4 years. Okay, and if you get the present value of 60,000 in year one, 30,000, the cash flow in year two, 30,000, the cash flow in year three of 40,000, and the cash flow in year four, 50,000, their value as of year zero or their present value compared with the deducted from the cash outflow 50,000, you will have a positive 93,542. So the answer here would be Bravo. The rate that you would be using here is the 10%. Next, an acceptable net present value has. Okay, so this is a tricky question, so please remember this one. If it is either equal to or greater than zero, so that means an NPV of zero is still an acceptable project. Okay, but of course, you choose the one with a higher net present value. But again, if you can accept multiple projects with zero NPVs are still acceptable. Okay, projects that are unacceptable are those that have a negative net present value. Next, internal rate of return is best described as the discount rate, which equals all cash, which makes the NPV equal to zero. So the answer there would be letter B. Okay. So again, your net present value is the present value of your cash outflows minus the present value of your uh, the present, you start with your inflows, the present value of your inflows minus the present value of your outflows using the required rate of return. So in the NPV, the uh, rate is given and you are trying to get the difference between the present value of the inflows and the present value of the outflows. In the IRR, you will assume that the present value of the inflows and the present value of the outflows will be equal to zero, meaning under the IRR, the net present value would be zero. Okay, what is unknown in the IRR is the rate of return. The rate of return that would make the present value of the cash flows equal to the present value of the inflows. Okay, again, your internal rate of return is the interest rate that would make the present value of the inflows equal to the present value of your outflows. Or in other words, the internal rate of return is the interest rate that would make your NPV equal to zero. Because again, how do you get your NPV? You get your NPV by deducting the present value of your outflows from your present value of inflows. Okay. Next, calculate the IRR. So please, one way of solving this is by doing trial and error. You use one of the choices and you get you apply the rate here in getting the present value of the cash flows. And if your NPV would be zero, then that would be your internal rate of return. Okay, or you could use the uh, calc function of your scientific calculators. Okay, or again, you can interpolate, but again, that will require you to use trial and error. So the answer here would be 10%. Answer number 18 would be letter A, 10%. Next, if the NPV project is 500 and the required rate of return is 8%, the IRR must be. So here you'll just have to analyze. If the rate of return is 8% and it has a positive net present value, remember that in IRR, the present value would be zero. So if the NPV is 500, what does that mean? The present value of the inflows is greater than the present value of outflows by 500. And what's the scenario in your IRR? The present value of the inflows is equal to the present value of outflows. Okay, so if you discount the inflows and outflows using 8%, the present value of the inflows is greater by 500. Okay, so the goal then now is what would be the rate that would bring down this net present value from 500 to zero. So basically, the net present value is 500, and we want it to go down to zero. And in that case, based on how present values behave, what do we expect to be the IRR? Do we expect it to be greater than 8%, or do we expect it to be lesser than 8%? Okay, so what then is the effect of your discount rate to the present value? The higher the discount rate, the lower the present value. So, and that's exactly what we want to do. We want to bring down the present value of 500 to zero. So that means we will need an interest rate that is greater than 8%. Okay, again, the higher the discount rate, the lower the present value. Okay, so we know that if the discount rate is 8%, the present value of the cash inflows would be greater than the present value of cash outflows by 500. We want to bring the difference to zero, so we need a higher discount rate or interest rate. So that's why the answer here would be letter A, greater than 8%. Next, given the following information, calculate the NPV. Initial investment is 50,000. Inflows for the next 4 years are 12,000, 4,000, 12,000, 13,000. The required rate of return is 8%. So basically the same procedure. You get the present value of the 12,000 discounted for 1 year. You get the present value of 4,000 discounted for 2 years. You get the present value of the second 12,000 discounted for 3 years. You get the present value of the 13,000 discounted for 4 years. You add all those four, and then you compare it with the initial investment of 50,000. Uh, Whatever is the difference would be your net present value. If the outflow is greater than the present value of the inflows, then that would mean you have a negative net present value, and which is the case in this problem, which we can easily confirm because even if you add the undiscounted cash flows, 12,000 plus 4 plus 12 plus 13, that would be 24, 28, 38, 41. So even the undiscounted cash flow is already lesser than the initial investment. Now, once you get the present value of that 41,000, you expect that to be even lower. Okay, and the answer in this problem is letter D, 16,378. So make sure to practice this problem. Okay, 21, basically a simple definition, very objective. So just make sure to absorb this one. Independent projects are letter A, those that do not compete with each other. The opposite of this one would be your mutually exclusive project, meaning accepting one would lead to the rejection of the other. For independent projects, you can accept projects, as many independent projects as there are, provided they are all acceptable, meaning they have positive net present value or their internal rate of return is greater than your hurdle rates. 22, the project selection method most consistent with the goal of shareholder maximization is letter C. Okay, again, this is considered to be the superior uh, investment analysis method or the project selection method. The net present value is considered to be superior. The answer here is letter C. Okay, NPV represents the dollar change in firm value resulting from undertaking a project. Okay, so basically the NPV tells you the value that the project would be able to give the additional value the project would be able to give to the company. Next, the relationship between NPV of a project and the required rate of return is negative. Letter A. What does it mean? The higher the required rate of return, the lower the NPV would be. Okay, the lower the required rate of return, the higher the net present value would be. Okay. 25, the NPV profile. Again, another objective question. The NPV profile is letter C, shows a graph of a project's present value given different discount rates. Okay, so if you see an NPV profile, you would see a project being plotted on the graph. Okay, and normally it would be downward sloping because again, the higher the interest rate, the lower the net present value. Next, a project is accepted if its IRR is letter D, equal to or greater than the hurdle rate. Okay. 27, the IRR is the point on the NPV profile where the NPV is equal to 0. The answer here is letter C. Here, another practice problem for IRR. Again, you can use trial and error here. The answer number 28 would be 16.4%, letter C. Okay, so make sure to practice on this problem. Next, 29, in case of conflict among mutually exclusive projects, the one with the highest NPV or net present value should be chosen because again, we consider the NPV as the superior project selection method. So the answer in 29 is Bravo. Number 30, for a high risk project, the analyst would, letter C, adjust the discount rate upward for risk in the NPV uh, form. So again, the answer here is letter C. 31, given the following information, calculate the net present value. So here again, you determine your initial investment, your cash outflow. So your cash outflow here would be 165. Okay. And then you get your net cash flow, 15,000 plus 20,000 minus 10,000 plus 30,000 plus 50. You will get a total of 30, 60, 110 minus 15, 20, 35, 65, 115 minus 10, you'll have 105. If you discount 105 by 9%, uh, then you deduct it from 100, and then you deduct 165 from it, you would get 88,377, a negative amount. So the answer there would be delta. 32, given the following information, calculate the IRR. So again, just look for the interest rate that would make 20,000 equal to the present value of 6 8,000s. Okay, and the answer here would be 33%. Okay. 33, given the following information, calculate the payback period. This time we're asked for the payback period. Initial outflow is 20,000. Cash inflows for the next 6 years are 8,000. Okay. So after 1 year, you have 8. After 2 years, you have 16. So after 2 years, you will have 4,000 remaining unrecovered investment. 4,000 divided by 8, you will have zero point 0.5. So a total of 2.5 years. Or alternative solution, 20,000 divided by 8, that will also give you 2.5. Uh, Here, question is uh, expected rate of return on the entire portfolio. Okay, so weighted lang. You just get the weighted average. Okay, so before the project, the expected rate of return is 10%. Then a new project addition is being considered. The new project would comprise 40% of the entire new portfolio. The expected rate of return of the new project is 11%. So with the addition of the new project, uh, which has an expected rate of return of 11%, you would expect that the expected rate of return in the entire portfolio will go up. Okay, the average was 10%. Then uh, there's an injection of a project that has an 11% rate of return. So you're asked how much then would be the expected rate of return for the entire portfolio. So since the new project will comprise 40% of the total portfolio, that means the existing project will now comprise 60%. So you get 60% of the 10%, you get 40% of the 11%. You add the two to get the 100%. Your answer here would be 10.4%. Next, the incremental cash flow can best be described as the relevant cash flows of a new project. So the answer here is letter B. Next, which of the following is not a major stage in the capital budgeting process? The answer here would be letter B, establishing betas for the firm. 37. A problem with the NPV method of capital budgeting is it can be difficult to explain to non-financial people. The answer here would be letter C. Okay, letter D is wrong because again, the net present value takes into account the time value of money. That's why we're getting the present value of your inflows and outflows. Letter B is incorrect. You only get one net present value. This concern of having two different values is common in the IRR method. Sometimes a project can have multiple internal rate of returns. What does that mean? A project, there are more than one interest rate, there are more than one level of interest rate that can lead to a net present value of zero. And normally that would happen if you have irregular cash flow, meaning uh, your cash outflow does not just happen in year zero, you have cash outflows even on subsequent periods. Okay, ordinarily, uh, investment will happen in year zero, and subsequent to year zero, you will just have cash inflows. Okay, but it's possible for a project to require an additional investment down the road, and in that case, it can result in a scenario wherein you will have multiple levels of interest rate that can give you an NPV of zero. There are multiple interest rates that would make the present value of the inflows equal to the present value of outflows. Letter A, of course, that's wrong because the net present values are not in percentages, they are in terms of monetary amounts. And the amounts here represent the amount of value that will be added to the company. Another objective question, the hurdle rate is no, that's not the number of years. Basically, your hurdle rate will serve as your required rate of return. And normally, the hurdle rate would be your WACC, your weighted average cost of capital. Okay, let's answer 39 to 43. What is the project's payback? The initial investment is 50. And then in year one, you have 20. In years two and three, you will have 15 and 15. So, year one, 20. After 2 years, you will have 35. After 3 years, you will have 50. So, you'll actually be able to recoup or recover your investment of 50,000 after 3 years. So, that's why the answer in 39 is letter B. What is the project's NPV? Here you will use the discount rate of 11%. You get the present value of 20,000 discounted for 1 year. You get the present value of the first 15,000 discounted for 2 years. you get the present value of the second 15,000 discounted for 3 years. You get the present value of the 10,000, the last cash flow discounted for 4 years. You use 11% in discounting those cash flows, and then you deduct the initial investment of 50,000. You would get negative 2,252. So the NPV is letter A. What is the project's IRR? So please practice here. Since the NPV is negative 2,253, and remember in IRR the NPV is 0, so that means we want it to increase from negative to 0. And based on the current uh, discount rate of 11%, it has a negative NPV. So what do we do with the discount rate? We expect the internal rate of return to be lower, because the lower the interest discount rate, the higher the NPV. We we need a lower discount rate because our NPV at 11% was negative. We want the negative amount to be 0 for us to determine our IRR. So we would expect that our answer here would be lower than 11%. And true enough, 3 of the 4 choices are lesser than 11%. Okay, after using trial and error, your answer here should be 8.63%. We will skip MIRR. I don't think there will be questions asking you to solve for multiple internal rate of return. So the MIRR is another method which addresses the concern of having more than one internal rate of return. Okay, as you recall, uh, if you recall, this is common if you have cash outflows. If you have cash outflows after year 0. So just for your information, under the MIRR, basically the same concept. You look for the interest rate that would make the present value of the inflow equal to the present value of the outflow. But in this case, since you will have multiple cash outflows, what you will do is to get the present value of your outflows. Okay, you have an outflow that is not on year 0, you bring it back to year 0, and you add it with the initial investment on year 0. So you get the present value of your cash outflows. That would mean the initial investment plus the outflows on the subsequent periods. Next step, you get the future value or the terminal value of your inflows. Okay, you get the future value of your inflows as of the end of the project. So outflows, you bring them to year 0. Inflows, you bring them to the last year of the project. And with that, you would end up with 2 remaining cash flows. Okay. So again, the challenge in MIRR is that the scenario here is you have a lot of cash flows and you even have multiple outflows. So to simplify that, you get the present value of your outflows, then you bring forward to the end of the project all your inflows. So what you will have now would be the value of your inflows as of the end of the project and the value of your cash outflows as of year 0. So if you have a 10-year project, you will get the present value of your cash outflows as of year 0, and you will have another cash flow which would serve as the value of all your inflows as of year 10. Once you have reduced your cash flows into 2 groups lang, year 0 and the last year of the project, you now look for the interest rate that would make the present value of this terminal value equal to the present value of your outflows. Okay, so in our example, you have a cash flow on year 0, another cash flow on year 10, which we will call as our terminal value. You will now look for the interest rate that would make the year 10 cash flow equal to the present value of the year 10 cash flow equal to your year 0 cash outflow. And that would give you your MIRR. And for those interested, the answer here for number 42 would be 9.73%. Okay. Now, should the company accept the project? Uh, let's check. The discount rate is 11%. So the answer here would be no, because it has a negative. Uh, it has a negative net present value, and the IRR and the MIRR is lower than the discount rate or the hurdle rate. Next, 44. Which of the following which of the following is a correct capital budgeting decision rule? The answer here would be letter D. Accept a project the IRR is greater than the hurdle rate. Okay, let's try to go over the other choices. So again, the answer is letter D. Letter A. Accept a project the required rate of return is greater than the uh, no hurdle rate. No, this choice does not even make sense because your required rate of return will be used as the hurdle rate. B. Accept a project the hurdle rate is greater than the required rate of return. Still no. Accept a project the hurdle rate is greater than the IRR. So that would be the exact opposite of our answer. The answer here is letter D. Accept if IRR is greater than the hurdle rate. 45. In capital budgeting, a project is accepted only if the internal rate of return is equal or exceeds the required rate of return. So the answer here is letter A. Next, 46. Which of the following is correct? Uh, the answer here would be letter A. Only incremental cash flows are relevant in capital budgeting decisions. Letter B is wrong because, again, payback period method does not consider cash flows after the payback period. And then letter C is also wrong because IRR is not preferred over the NPV method. 47. Uh, Project X has an internal rate of return of 20%. Project Y has an internal rate of return of 15%. Both projects have a positive net present value. Which of the following statements is most correct? Project X must have a higher net present value than Project Y. Let's see. IRR. Uh, IRR is 20% for X, 15% for Y. Both projects have a positive net present value. So that means the 15 and 20 are all greater than the required rate of return. And then 15% is equal to 0. No. When subjected to the same required rate of return, uh, project it's not project X does not necessarily have a higher net present value. Letter B, if the two projects have the same WACC, project X must have a higher net present value. Again, still no. Project X must have a shorter payback period. Again, can be determined. The answer here would be letter E. Okay, but I don't think the questions would be this difficult to analyze. 48, a capital's investments internal rate of return Uh, is the answer here is letter E. C and D are correct. Must exceed the cost of capital in order for the firm to accept the investment. Okay, IRR must be greater than your WACC. Is similar to the yield to maturity on a bond. Okay. Next, 49. Which of the following statements is most correct? The modified IRR method. Uh, Letter A always leads to the same ranking decision as NPV. No. Overcomes the problem of multiple internal rates of return. Yes, that's what I mentioned earlier. Letter C is also true. Compounds cash flows at the cost of capital. Compounding means getting the future value. Getting the value of the cash flows to the uh, last year of the project. Okay, the answer here would again be letter E. And then number 50, which of the following is most correct? Our answer here is letter E. So that means all the choices are incorrect. Um, the NPV and IRR rules will always lead to the same decision. That's wrong. The modified internal rate of return compounds cash outflows at uh, the modified compounds cash outflows. Letter B is wrong because you do not compound the cash outflows, you compound the cash inflows. Letter C, conflicts between NPV and IRR rules arise in choosing between two mutually exclusive projects when the cost of capital exceeds the crossover rate. Uh, the conflicts between NPV and IRR rules arise in choosing between two mutually exclusive when the cost of capital exceeds the crossover rate. Um, if cost of capital is greater. No, it's the cost of capital is lower than the crossover rate. Next, the discounted payback method overcomes the problems that the payback method has with cash flows occurring. No. After, so letter D is also false because the discounted payback also ignores the cash flows after the payback period. The problem that the discounted payback solves is that it now takes into account the time value of money. Okay. I'll end the explanations at number 50. I'll just give you the answers for 51 down to the last question. 51, the answer here would be letter D, A, and C are correct. 52, answer here would be letter A. 53, the answer here would be uh, letter A as well. 54, answer would be letter C. Number 55, the answer would be letter B as in boy. And then 56, the answer would be letter A. 57, the one in number 57 is now the NPV profile. And the rate at which the uh, NPV line of project A and B intersects is what we refer to as your crossover rate. Uh, so 57, the answer there would be letter B as in boy. 58, the answer there would be letter D as in dog. 59, answer would be 59. Answer would be, wait, projects A and B are mutual normal cash flows. Projects A and B are mutually exclusive projects. Answer here would be letter E. 59 is letter E. 60 is letter E as well. 61 is A. Project excess NPV must be positive. And then 62 is Bravo. 63 is Alpha. 64 is Alpha. 65 internal rate of return is 15. 65 answer is Alpha also. 66 is Bravo. 67 is Delta. 68 is Echo. 69 is Echo. 70 is Bravo. 71 post audit. The answer there is Delta. 72 answer is Bravo. 73 answer is Alpha. 74 answer is Delta. 75 is Delta. 76 is Echo. 77 is Charlie. 78 incorrect Alpha. 79 Echo. 80 is Alpha. 81 is Charlie. 82 is Delta. 83 is Bravo. 84 is Delta. 85 is Alpha. 86. Make sure to practice 86. 86 is Alpha. 87 is also Alpha. 88 required rate of return. 88 is Delta. 89 Charlie. 90 is Delta. 91 is Bravo. 92. 92 is Alpha. 93 is Delta. 94 is Alpha. And then uh, 95 is Bravo. So although we don't expect the questions to be similar to the second half of the handouts, but if you have time, go over them, and especially in the theories, and practice also on the problems. Okay, so that would be all for NPV, IRR, and payback. Okay, and nothing beats practice, and hopefully you'll be able to absorb the objective concepts introduced in this practice question. So good luck on everything.